Hi, I'm Will Harris, and I'm going to be taking you through this Flame 2011 presentation of new features. And there are three main parts to what we're going to see in the next hour. We're going to see about our pixel shader, our 3D VFX integration, and stereoscopic 3D. So I'm very excited to show you some of this new functionality, specifically relating to the pixel shader and lighting and quality improvements inside of Action. If I was trying to produce a background that might look something like this, this is just a still from a piece produced by the mill called Caterpillar. So, I'm going to use Action here just to work with some stills and give you an idea of the kind of creative design that you might do for something like this. Using this new functionality of Flame 2011, I'm going to just start by cutting out a leaf here, and I'm going to use a couple of lighting techniques as we go along here. Some that you'll probably know, some that you don't. For example, displacement map would be one that you're probably quite familiar with, but indeed parallax map is a new functionality here in Flame 2011 that allows us to get relief, or like the ability to do more realistic lighting via the textures internal in this kind of an element, which is kind of cool. So let's just take our leaf, and if we go ahead and add a light into the scene, you'll notice right away, perhaps, that lights look a little different. So if I move this light back, increase its intensity a little bit, you'll get an idea as to how this pixel shading is able to deal with this kind of natural blooming of light in a very interesting way. So I'm going to take a look at displacement, working with the background layer here. If we just switch to a 2-up view here, you could see that these different layers, I'm just going to go ahead and add a displacement of itself to this layer, and there are a bunch of new maps in here. We're going to come to those as we go along. Right now I'm just going to use a displacement map for this sort of background, slightly out of focus background here. So if I just go ahead and do this sort of displacement effect here, just making sure we perhaps push the layer back a little bit. By the way, I could use my auto sizing here, where I actually am able to push the layer backwards and it automatically scales, which is a very useful tool here in 2011. I'm also going to take my shininess value here to get this kind of shrink wrapped effect. Of course, softness works the way it used to, and you can get some real interesting kind of effects here. Specifically though, you might want to take a look here at the resolution setting, which previously it might not have been so much fun, but now you can actually use it in a kind of a creative aspect here via softness. You can get some interesting kind of effects going, or indeed if you crank it back down to sort of a low resolution here, you can actually get a super clean fine result. The reason for this is that our pixel shader is doing, like it says, shading pixel by pixel independent of the mesh that you might be forming for your image. Each pixel is being lit individually, and you get this super high quality. Just turning on my working camera there, this is a new function that allows us to look at the scene like a static perspective view in a CG application without adjusting our main camera, if you like. So if I just go ahead and add some of this shiny characteristic to our leaf, you can see that we get an interesting look here. As I move the light around, you can see how it responds. Indeed, if I move back my working camera again, you'll see how the specular highlight here actually moves based on the relationship of the light, the object, and the camera. So this is real naturalistic lighting. Coming back here, what I'd like to do then is I just wanted to use displacement. Perhaps I think that you'll find in this case that displacement may not always work. We know that from experience. Based on the luminosity of the image, this is not quite the right fit here. It's interesting, but it's not naturalistic. Parallax mapping is a new technique that comes from the sort of the games world, games engine relief or z-depth adjusting to produce a result that actually gives you a sort of an interesting effect here. If I just turn on the generate normals setting here, use a little attenuation to even out my leaf. It's funny that it's called generate normals because look at the result we get here, where it actually appears almost like we have a sort of a computer generated leaf with a normals map, if you're familiar with that. We're just generating this simply based on just the luminosity here in the image, just like displacement mapping. But what a great combination with lighting here. If I just give my leaf a little turn here, you better get an idea as to how this works. So as I turn through here, you can see the light really responding to it in an interesting way. Indeed, if I take my parallax and just soften it a tiny bit, this is like softening normals, and of course you can get an interesting different effect. Another cool new functionality is the use of shaders, and these are reflectivity attribute adjusters that can be managed on a layer by layer basis. So what I mean by that is, if you're familiar with different types of shaders in the CG realm, you might have heard of anisotropic shading, Cook Torrance shading, perhaps Fresnel shading. And indeed, if I use this anisotropic as opposed to the default shading here on the flame, we now have this highly reflective sort of chromey-like surface just on the leaf. So I've made a lighting relationship here between this shader and this leaf. If I switch over to a Cook Torrance, you'll see how I can get this really interesting kind of specularity that's working here. And of course, if I rotate my object here, you'll get that sort of super shiny kind of jungle leaf working here. I think you can already see how interesting it is to be able to get this kind of sort of photorealism via lighting right here just from a still. Another one that might be relevant here might be our Fresnel shader, which if we adjust a few values here, you'll start to get an idea of just how this might be a sort of a naturalistic kind of look here. We adjust our roughness and get ourselves a real sort of realistic light for our leaf. Of course, this interacts with the overall shininess of the image as well. This is just a really cool technique to work with, and it's emphasized further if you take your layer here, perhaps switch it over to like an extended bicubic, say for example, and in this case I want to take my leaf and actually use, like I was saying earlier, some old techniques that now are just sort of super improved by the overall quality. So if I just bend my element here, you can get an idea as to how the light reacts in an interesting way based on the shape and orientation here. I'm just working with the bicubics to get sort of an interesting roll off on my leaf as it suits me. So there you go, you can get something like that, which if I then were to work with, you can see how the leaf now reacts to light as a bent, deformed layer here. Kind of an interesting way of working with it. So if I just place it over on this side, I'd like to just bring in my last layer here, this branch. This one I can also use a displacement effect with, but of course I'm going to use a different shader for this layer. So I want to actually just line it into place with my leaf. And the great thing about shaders is that you can use multiple shaders within a scene. So for this this guy right here, I want to actually use a nice soft displacement, but also a specific shader that will give us a different look, so that albeit that we just have one light in the scene here, we're able to set different reactivity properties for the different objects. So say for example here we could build ourselves a sort of slightly rougher kind of branch here, and my shader is in fact affecting exactly how that reacts to light, so that then when I move my light around within my scene here, you'll get the idea how this works. I'd like to create a dolly move on this scene, so if I just extend it a little bit and work with my camera here, I'll just start it right there, and then by the end of the scene I think we'll push in through. So I'll actually use a dolly for that, and as we kind of go past here, you'll be able to get the idea as to the changing perspective of our scene. So this might be part of the background build that we're working on for this shot. Perhaps we also would like to animate, you know, the rotation of our leaf as we go along. And then to just finish this off, I'd like to add a substance texture generator, and that is one of the new tools that really just takes all of these techniques, parallax mapping, working with lighting and shaders to the next level, and that works just simply by taking any image. In my case, I'm just going to work with a still of white here, and by adding that into the scene, what I'll do here is I'll just take one of those and I'll attach a substance generator to it. So that's one of our new maps. It's a substance texture generator, and I call it a generator as it is a procedural generator that creates an infinitely scalable, tileable and repeatable texture that you could use for all kinds of things, whether it's a wall replacement, a creative design effect over an image, or something totally practical like, you know, sand, different types of stones. I'm going to pick these pebbles here, and what you'll notice is that gives us a start here. I think I'll just define my own Z buffering here and put this guy back here for now. And the really cool thing about this is just how flexible it is. So if I wanted to adjust, say here, the hue of this to get my grass a little greener, I can do that. If I would like to take my my diffuse texture here and repeat it, I can do that. And you can see that we can get a large field, but where the really fun stuff starts happening is if I start rotating this, you'll be able to get the sense as to how the parallax mapping inherent in this element here, let me just show you the pieces, are what's enabling us to get this kind of real life perspective. The parallax mapping there is serving sort of like Z depth information. The normals allows us to adjust lighting, and we just get a very, very realistic simulation. You can see that even though I've got the ground upside down right now, it's reacting to this light. If I go ahead and turn this into place a little bit, you'll get an idea that this is just using this white card as a mounting point. If I roll it around like this and just scale it up, you could get the idea that just by simply dropping my ground down into the place where I want it, I can get an interesting result. As I scrub through here, I'm not sure how obvious it will be as you're watching this, but we do actually see a little bit of noisiness, graininess, being that we're tilting our images here at an extreme level and panning slowly past it. we do have a functionality here that affects many of the essentially when you're trying to move images in a subtle way. If you do see sort of filtering problems, we have a whole new slew of filtering, including this one, the EWA elliptical weighted average filtering. And this can help you if you specifically have this kind of situation. I'll just turn my filtering on and see if I can show you the difference between an image without filtering and with. If we just go from our linear filtering, which has this little wriggle to it, and indeed we switch over to our EWA filtering, perhaps you could get an idea. You should try this for yourself. This much smoother result on any kind of image, tilted, tracked, drifting around the screen. It's really cool. So to just finish off this build, I'll go ahead and reorder my layers to reintroduce our abstract background over sort of the back wall as it is over our image. And I just wanted to finish this off and process it out for you guys so that you can see the speed that we're able to work here even when doing this kind of lighting technique. So if I just cut myself a kind of a drop out here in this wall, you'll be able to see how this could work. This. And I think you'll be able to get the idea. I'll just manipulate this properly. We can go ahead and get something that looks a bit like this for a sort of a cutout of our background, and so we can see our stones before. And then of course as we track through the shot here, you're going to get this kind of an effect, seeing your ground below our funky abstract background. And of course if I process this out, even though you've seen this very high quality lighting, it just takes a few seconds to go through 100 frames of this with the texture generator and with this this sort of supernaturalistic lighting. So here's the result. So now we'd like to show you a workflow with Flare 2011, including a round trip with Maya. Flare is the creative companion system to Flame. It has the complete batch toolset and creative toolset of the Flame. We're going to show you a workflow with Flare, Maya, and then back to Flame. So in Flare, you have a couple of options. You can connect remotely to another system and open a project, or you can work on your own system. You are able to then open projects that are already open on a Flame, and work collaboratively. You'll see that we go straight into Batch, where we have all our nodes available to us to work with here, including action, including all the different keys, a completely unlimited tool set of work here in Batch. And if we go and look into our library here, you'll see that I can see all the different libraries that are available on the Flame as read-only. This one here could be my work in progress, where in fact I might want to make my own library here, so make a Dropbox perhaps, to give stuff right back to the Flame guy, right into a library here if I'd like. Another way of working could be to be working on set with your Flare. It'll run on a number of different systems, including laptops. You might start just with a few assets that you bring with you. For example, you might have a few images to work with, and perhaps some CG assets. I'm going to use the FBX import method here to actually bring in a couple of elements. You'll notice that FBX models can now be scaled I'm actually just going to use the 1.0 scaling here, as I'm going to do a round trip with Maya, so I want to keep the scale the same. So this is just a basic model, no moving camera, no real textures on this. If I just add a light to the scene, you'll be able to see here that I have a ability to add lighting here. And if I wanted to perhaps put in my background element, I could do that as another piece here. Just go ahead and send it back, use that automatic scaling if you'd like, but then also blow it up as well. We could then, if we move our camera, I'll be able to see how that works. In this case, I'd actually like to use a new type of camera called an FBX camera, and that's available here. You'll see in my schematic that if I go to my 2 up here, my FBX cameras, which are based on the Maya cameras, are actually able to be mono or stereo. I'm going to loop back around and show you some stereo functionality, but for now I'm just going to work with a mono camera using this FBX type of camera. And as I just work out perhaps some sort of move here, you could get the idea as to how I might be working, sitting with the director with a sort of a basic model here that over time I could go ahead and build myself some sort of interesting camera move here. Let's say we wanted to come all the way down and then zoom all the way in to look at the car from this angle, and then back here we're over on the wide. That could be my camera move. I could go ahead and work my image a little more to get a little bit more of all the stuff that you would do normally in your system, whether it's tracking, whether it's keying, whether it is working with these bicubics or whatever you need to do to get something that's looking kind of cool. But the main thing I want to show you here is how you would then go from this environment, working in Flare, but with the Flame toolset, into the actual Maya environment. So if that's the way we want this to look, go ahead and pull our image over. We've got our camera move, something like that. The next step would be really 2 parts to this process. One would be, if we were leaving the set now, would be to actually save this so that the Flame could pick it up later. The second thing would be to actually output our camera information for our Maya artist to use with the much higher quality models to produce us a render. To save is very straightforward, simply a process here of saving either in your user or project bin or saving the batch itself. I'm just going to put it in my my user bin here, and that will then be visible for the Flame guy when he wants to bring it in. In terms of my camera though, I'd like to actually perform an FBX export, so I'll go down here and I'll build myself an action cam from Flare. This is going to build a camera, and indeed if I have any locator points or a point cloud from a 3D tracker, that would also be sent over to my 3D artist. The FBX format allows us to interchange geometries, cameras and lights between Autodesk applications. So I'm running Maya here on a Mac Pro, and I'll just go ahead and open the scene that is about ready to render, except it needs our camera that we generated in Flare. So if I just go to import here, I'm going to import that FBX camera that we just generated, the action cam from Flare. And what you'll see is that it just gives me one more choice of visible cameras. It's my camera 1, which you should now recognize with the same framing, same gate, as they call it for the actual framing of this camera, and giving me the same perspective as I just had on my sort of basic model from earlier. That is really all there is to it. The next thing to look at might be to go ahead and taking a look at render passes, so that you would know what to ask for should you be working with a CG artist. They've got your camera in place. They can go ahead and use that camera as their renderable camera, and it's important, especially when working with OpenEXR format, to take advantage of the other auxiliary information that you can get via what we call AOVs on the CG side. So you have a beauty, but you also have different passes or ways of isolating, whether it's the paintwork of the car, the wheels, the ground, or just the car without the ground. We also can produce motion vectors in a format that Flame and Flare can understand, as well as perhaps reflection passes, shadows, or indeed you might want some normals. We're going to generate world-oriented normals here for relighting this render back in Flame. So back here in Flame, I'm going to take the work that the Flare did along with those EXR renders that we produced from Maya, and I'll start with the work the Flare did. They actually saved this custom node, which is an action, here in the user bin. You could also save it in the project bin or as a batch setup itself. That's one of the great things about working with Flare. Anything that they do is 100% compatible with me, so I can just pick up, modify, use what they gave me. In terms of the EXRs, here in 2011, I'm now able to directly reference them. What I'm able to do here, if I just go via the network browser, you can see I'm using the gateway to browse to a location here on our SAN, which gives me if you like, a mount point for these EXRs, and I can open that multi-channel EXR directly there. I'll just go ahead and load that straight in as a group. And that's how easy it is to open OpenEXRs. If I just step through my passes here, you'll see the different elements available to me. So I'm going to just take the pieces that I want here in action. Just take a couple of pucks there and go ahead and take the beauty pass of this car with the opacity for the car. And I'm also going to grab the normals right now, those world-oriented normals that we'll be able to use for relighting. Here in the scene, of course, we would want to actually, we'll use the normals in just a moment, but we would want to orient our render to the camera, right? So it has the camera move baked in, so we'll just negate that by coming in here and just rolling this render back. Perhaps a technique that you've seen used many a time, just by reframing it to the size that I want here. I should get me a nice reframe of that. The lighting is perhaps not going to work right off the bat, so I'm just going to take what the Flare did and work with it. I'm going to parent my light down there from my camera, and if I just go ahead and position the light, you could get the idea that I can get an interesting effect here, but of course it's not quite the full package, as I'm just lighting the image via the luminosity of it at this point, and I want to actually use those normals. So this is really cool if you have it. One of those things to ask for from your CG artist would be a world-oriented normals in the case of a moving camera move, allowing you to use your lights, position your lights, and you can see, especially if I move further in the scene here, you'll be able to see how I can get quite dramatic lighting effects if I'd like, much more than I can without normals. And if I just make my lights static there, and as we move by, you'll notice that essentially I'm able to do my lighting based on the orientation that I want. If I bring my light down really close there and drop him right in, so for this kind of angle, I'll be able to get a kind of a neat lighting effect that stays relative. Obviously the car moves past the light, but my normals are helping me have meaningful lighting here for my scene. Next thing to do might be to take this cylinder, which is just a geometry in the scene, and actually assign it one of our substance texture generators. So what I'm going to do, let me take this geometry, just like with video, you can also assign our substance generators to geometries. If I scan through here, you can see all the different available ones. We really like these. Let's go ahead and just get some road, would make sense. And what you'll see here is that I'll now have a generator based from my geometry here. And if I just work with it a little bit here, just go ahead and set it to repeat, perhaps rotate it around a little bit. Indeed, I might also just scale my cylinder a little bit more to get it just about the right size. Of course, I can move this guy so that the road goes past the car if I'd like, as I animate through. And you can really get an idea that this light is, I've just got one light in my scene, but you can really see how it's lighting both the substance generator and the car. In a slightly more refined example over here, I actually have an example which goes a bit further using a few more passes. And this one here, we've actually gone ahead and used the ambient occlusion pass and reflections, also observing normals, to get a result that looks a bit like this. So you can imagine, if I just show you my schematic here, you can see we're using our occlusion pass, we're using reflections, and our lights are now able to react to those reflections independently. I've got one for the backdrop, of course, and indeed the road itself, which is actually this one right here, can be all lit independently. So let me play you back that result. New to 2011 was the introduction of stereoscopic tools, and there are several components to our stereo toolset. The Stereo 3D timeline, the real-time stereo viewing and effects, our stereo objects, and of course our maps, the ability to output stereo, and the FBX camera. So you don't need to wear your 3D glasses all the time. I'll tell you exactly when to put them on as we actually play back the stereo material, but I'm very excited to show you this stereo functionality here in the Flame. I'm going to start you right off with the way that we get material in, if it be stereo. In this case, I'm actually going to acquire some red material, also through our wiretap gateway, just like we do with we just did with the EXRs. This time I'm going to go in, use a bookmark to take me straight to my red material, and you'll see that that's just opening the folder here on my SAN, and that gives me this same mount point. I'll just use a dual up here so that we can examine our red as it lives out on the file system, and use the previewer here to actually scrub through if we'd like. You can see that there's a left and a right. This one's a flipped rig. But I can go in right here and using my in and outs if I'd like to define the area of the shot that I'd like rather than the entire red take. You can see all the metadata that's populating here, the settings. There's obviously a lot of settings that relate to how the red is debayed, which is all available to us here. The different formats have their different metadata settings. So I can choose, for example, that I'd like to work from the half good red material here, and perhaps override the camera settings here and use my own settings, because I think I know better. Perhaps I'm going to go ahead and interpret a higher exposure, and as I drag this clip in, what you'll see is that gives me that higher exposure. It shows me the size here that I have. I can do the same thing with the other one if I'd like. So that's my two eyes. In fact, if I had a situation where I wanted to change something, import history then kicks in. If I go ahead and click the clip, I can then change the way I brought it in. So say for example I do need my my full debayer in this case, and I want to go back to the camera settings. I'm able to do that, as well as, if I'd like, store a local copy. And what this does is actually cache the full res. It could be up to 4K in the case of red media locally, as well as maintaining a link to that original media. So once you have your clips, you can go ahead and work with them as stereo tracks. If I just pick my left and right for both these shots, that gives me 2 clips which are now ready to go. I could of course then just come through here and perform normal editing with these stereo clips. You'll see the little S in the corner indicates that they're stereo, and if I open them into the player here, you'll then be able to see further that we have this special type of track, a stereo track, which has a left and a right. This timeline is incidentally completely compatible with the Autodesk Flare, Smoke, and is transportable over to Lustre as well. Anything I do here you can see is synchronized, including transitions, which will happen on both eyes if I so wish that, as well as color corrections, blow-ups. I also have a break sync mode where I can actually change stuff individually. Perhaps one eye was a little larger or smaller than the other. I can adjust that there. So that's editing, but I also want to take you guys into a little bit of information about the stereo formats that we support, and then we're going to move into batch and do some compositing with stereo. If we take a look in our preferences, under broadcast monitor, you can see the different formats of stereo output that we support via our preview. You can do the anaglyph in the various different views of anaglyph, the Dubois method for noise reduction, a mono and a difference or blend modes here if you'd like, as well as the interlace format, which is appropriate for feeding LCD interlace monitors, which there are a few available now, as well as the dual output, and that dual output actually allows us to output 2 full resolution eyes, so the left eye down your A-Link HDSDI in 422, and then your B-Link SDI would be that right eye, full resolution. So this is appropriate for sending to a monitor that can support 2 full resolution eyes, or indeed a projector. So that's really cool. We take a look at our timeline in the anaglyph view. You can go ahead and put on your glasses now if you'd like. As we play through here, you'll be able to see that stereo effect right here on the UI. As you know, anaglyph works on any format, even comic books or stickers. And our other options here would be the anaglyph mono view, which is really just a way of sort of extracting your stereo without considering the color offsets that happen when looking at anaglyph. Or indeed, if we wanted to, we could look at a blend of the 2 eyes, or a difference that actually gives us, if we show you the clamped version here, the stereo separation as amplified here through a difference mat. So those are useful ways of working. If we go into batch here and start working with the stereo footage, what you'll notice is that as I bring up this stereo clip, the thing that's different is that this clip has 2 fronts. It has a left and a right front. And indeed, you might be wondering, well then how do you work with it? Do you need 2 of everything? And whilst the answer is yes, you do, we have a macroized version of our nodes here. So as you pull them out, you get 2 linked nodes. What I mean by that, let me show you, is if I just connect this color corrector here, you'll see how if I take a look here, I've got a left and a right eye. So if I just make a quick grade here, you'll be happy to see that this is happening on both eyes. So if I just wire this in a little bit like this, add a little gain and saturation perhaps, and flick between the eyes, that grade is applied to both. However, what can happen with live action shot material in stereo, and seems to often does happen, is that there can be a discrepancy between the cameras. We can deal with that pretty powerfully here. You can see inside my group I have a duplicate node, just like the action duplicate node, and I'm able to go in here and let's bring out another color corrector, and let's go ahead and use the other eye as our back or reference here. And if I just grab my back here and use my split bar, you can see now in the color corrector here we can see the different eyes. And if I just go down here and pick a front and a back about that same location, you'll see there's a subtle difference. If I use my curves to go ahead and match that, that's giving me essentially a technical grade match upstream of my of my creative grade here. So it's just a useful way to work. If you knew that you wanted to, you could always just turn that one off as well and keep it clean for continuing on down the line with the other nodes that you want to work with here, so they can all be used as stereo. The one notable exception to this is indeed action, and if I pull out an action with my stereo Shift-S macro, I actually get this special version of action which is already formatted for stereo. If I go in there, things might look the same to start with, but you're going to start to notice some differences. If I look at my top view here, you'll be able to see that if I zoom in on my cameras, there's actually a full camera rig here. That's the FBX camera, which is based on the Maya camera. I can manipulate it. It's like a real virtual camera rig that I can adjust, and you can get the idea as to how these different cameras get a different perspective of objects that you throw in front of them. That's the fundamental process here that we're going to be looking at. In terms of loading footage into the system here, what I'm going to do is add a stereo clip, and what you'll see is add this stereo clip directly here, and it actually loads two layers, a left component and right component. And without the mat there for a moment, what you'll notice if I look at my schematic here is that I have my stereo camera and I have what's called a stereo object. I also have on the output side a stereo output. So those are three components that allow us to work in action in stereo. Indeed, if I just process this out now, it would pass through in Unity. What I could also do though is to actually manipulate either the camera itself or individual objects' stereo attributes. What I mean by that, if you put your glasses on again, you'll be able to see when I adjust the convergence that what's really happening here to the image is that I'm actually changing that zero parallax. I'm adjusting the screen reference by changing convergence. There's a lot more that I can adjust as well. For example, if I wanted to amplify or reduce the overall stereo effect, I can actually adjust this field of view offset and get a different kind of look. You'll probably see it changing. I hope it's not hurting your eyes too much. But here I've just essentially amplified the stereo, and if I then take this guy, and if I wanted to go a little further, I can go into the actual textures here of the eyes and break sync. Sometimes what happens is that you'll have a slightly different perspective on one eye versus the other, and you'll start to see drift. So you can deal with rotational problems, shifting problems. You have a complete, essentially like a DVE here. Let's say, for example, you had a kind of shearing problem from one side on your left eye here, and you can go ahead and change the way the image actually breaks apart here if you'd like to get this kind of an effect to line up your tree like so. If you need further manipulation, you can actually use a source front here if you'd like to go even further with the image. If you turn it into an extended bicubic here and actually just take a look at that front, you'll see that the left eye here, if you had a distortion problem, you can actually move it relative to that right based on all of the tools that would be available to you for normal manipulation. So the next thing I'd like to address is, what if you actually wanted to do compositing within this stereo framework? How does it work? So essentially, if I brought in a piece of text here, even if I just make it into, say, a simple capital I, and enlarge this guy a little bit so it's somewhat like a tree, if you're thinking in those terms, you can get the idea here that if I place a mono object into the stereo scene, whilst it's at the zero plane, it actually looks mono, but if I actually pull it forward here in the Z depth, you can get the idea that to about level of that tree there, you will see that it actually gets this stereo properties. The reason for this is simply because if I use my working camera view here, you'll be able to see that that bar is really closer to the camera, so it makes sense that the different cameras would view it differently and it would inherit stereo attributes. In this case, I'm doing this for a specific reason, and that is that I want to be able to have my objects move around and interact with the scene, the meat and potatoes, if you like, of normal compositing work. So what if I wanted this to move behind the actress here or behind the tree and integrate with our scene? This is where things might get a little more interesting, especially when you consider that the stereo is baked into, so to speak, the plates themselves. So how do we extract that? How do we work with that? And I'm going to show you. So if we actually line up our bar here in space so that the divergence, I'm looking at the gap or the red offset of the tree, similar now to the bar here, but the plate is not quite in the right place. So let's just start by making a map for this tree, and I'm going to show you how we can offset the position in space so that it's in the correct spot for compositing. So if I actually go in and start to roto out these trees here, I'll just load a mask for my left tree here. What you'll notice is that if I go ahead and copy that and paste it to the other eye, this is the right eye layer, there is a certain amount of difference between the two layers. That's because it's stereo, right? So you're going to expect to see an offset between layers. If I select the object here, you could just manipulate it in position. Some folks prefer to actually use rotation to really simulate the different perspective that a camera would provide. If I just rotate this by, in this case, just like 1 degree, and perhaps a little bit of adjustment as well, I've offset my left eye to produce a right eye result. So now you can see that separation that's happening there. Next thing to do then would be to actually pull the tree in, as it is in space towards the location that I want to work with. So I can move that in a number of ways. I can take my stereo object here and I can actually, of course, move it around like you would a normal layer, but I don't specifically want to change the stereo attributes of it. If I just move it, then you'll see that the stereo attributes actually change as we come closer to the camera. So rather than doing that, I'm actually going to use the auto scale function here, and you'll notice that as I pull it forwards, not only does our scale stay the same relative to the result camera on the right, but also as I keep coming forward here, I'm keeping the stereo attributes. If we just take a quick look at our element here, 533 forward is going to put us in just the right spot as we measured it, if you like, with our mono object. If you take a little more time to actually roto those other trees and push them back in space, also what you'll get is something like this. I'm looking at my working camera view here so that you can see that that back tree here is laid back in space, maintaining its stereo attributes via the auto scale function here. So this stereo plate is actually pushed back in the action comp, but by virtue of the macroized stereo object, it is actually being kept in its correct stereo convergence. So if we look at the two up here, you can see that the stereo still works, but the comp is now broken out in space. This would allow me to insert items into the scene. You'll notice that I've actually animated the position of the girl here walking backwards as she passes back all the way back towards the tree, and still maintaining the stereo object, the stereo attributes, but moving as a plate. This would allow you then to take a light like this and actually light the scene in an interesting way. I'm using the profiling here that you now have available for lights to build this kind of flashlight effect, and you can see how we can get a real interesting thing going on here as part of our way of working. A little further along, what I've actually done here is to plug in a background and actually add another mono element to the scene in the form of a moon. So the schematic for this one looks a bit like that. You can see the working camera shows those elements broken out, and like I was saying, the schematic here, you can see different stereo objects set at different places in different positions, and indeed this moon here is laid way back in the scene to give it a lot of stereo positive parallax. So I have one more example I wanted to show you that relates to taking mono work and converting it into stereo. We have a really cool piece here that was actually produced by the mill in New York, where a roller coaster flies through the city, and it was originally produced, of course, as a monoscopic piece, but I wanted to show you how easy it is in this case to actually convert something mono that uses naturally depth projections, the tools that we use every day in the flame, into a stereoscopic piece. So this is the comp, and as you can see, it uses keying, tracking, matte painting, the whole thing, but specifically I just wanted to show you how if we take the end result here, we're currently looking at a mono comp. What I mean by that is obviously we don't have a stereo camera in the scene yet, but as you can see, if I look up here, my sort of bird's eye view, my working camera, as I scan through the piece, you can get an idea of the kind of tricks that people get up to, of course, for being able to break apart the world of their scene. In this case, they're using an FBX model to make these basic buildings, and here's a little schematic where you can see the projectors being used. We've also added into this scene a stereo camera. So by just taking, if we just take for example our RenderCam 1 here, which is just the mono camera, it's really just a case of taking a mono camera and converting it to stereo to produce an instant stereo result. If you want to, you can actually start to see how these mono elements, of course the guy here on the roller coaster is mono, but the buildings in the background are getting their depth because they literally move in space, like you saw on the working camera. So if I actually take one of these buildings here, like the one on the left here, and rotate it a little bit, you'll see how its stereo attributes change based on where it is in space. And that's a really powerful thing, especially if you were trying to repurpose something that you'd already built, but for a stereo deliverable. If you have this kind of setup where you're using the space that's naturally in action to produce your effects of tracking, drifting, perspective, you can reuse those powerfully in the stereo field. So thank you for listening. This is a review of what we've just seen, and we're happy to take your questions. Thanks again for taking the time to watch this webinar.